Hey Wildcats, welcome back to the STEM Lab. Today I'd like to talk to you about force.
Concentrate. Feel the force flow.
No, not that kind of force. Well, not exactly. A force is a push or a pull that causes an object to move, stop, or change direction. We do see many examples of the force pushing and pulling in Star Wars, but unfortunately, we can't push or pull objects with our minds. I think the things we can do with force are pretty cool though. Today I'm going to show you 4 experiments that deal with force. What I'd like for you to do is get your science journal, and at the top of the next clean page, I want you to write the title, Force and Motion. Go ahead and pause the video so that you have time to write. I'd like for you to go back to your science journal and write the title of this experiment. It's like this, Strength of a Push. And again, pause your video so that you have plenty of time to write. For this experiment, I've made a pendulum using this metal ring called a washer, and the fixed point is where it is taped up here to the table. Watch what happens when I give the pendulum a soft push. And now watch what happens when I give the pendulum a hard push. All right, I'd like you to go back to your science journal, and I would like you to write soft push. Go ahead and pause the video so you have plenty of time to write, and then come back. What happened to the pendulum when I gave it a soft push? Think about that and write it in your science journal where you have written soft push. Go ahead and pause until you're done. In your science journals, now I would like for you to write hard push. And pause and come back when you're done. What happens when I gave the pendulum a hard push? Think about that and write that in your journal next to where you wrote hard push. How did the different pushes affect the pendulum? Both pushes made the pendulum swing, but they didn't make them swing equally, did they? The hard push made the pendulum swing higher than the soft push did. Our second experiment is called Make It Move. So if you'll go back to your journal and write a number 2 and the experiment title, Make It Move, pause and come back when you're done. For this experiment, I have a ramp, I have a crayon box that's empty. I'll let you see that it's empty. And I have a marble. So I'm going to do 3 different tests, and for each one, I'm going to let the marble roll down the ramp. I'm going to give it a soft push, and I'm going to give it a hard push, and we have a meter stick here, and we will measure how far the roll, the soft push, and the hard push moved the box. We'll see how many centimeters it is. But first, we have to go back to your journals. So what I want you to do, okay, you can see this table that I have set up. So I've got columns for roll, for soft, soft push, and hard, hard push. And then I have trial 1, trial 2, and trial 3. Because like I said, I'm going to do 3 different tests. So go ahead and pause, get this set up, and then we'll get to the experiment. Okay, so this is trial 1. I'm going to let the marble roll. All right, and let's see how far it moved. Pick up my meter stick, hopefully you can see this. It moved 6 centimeters, and my marble is trying to roll off the table. So what we'll do is come back to our table. We'll write 6 centimeters for trial 1 and roll. All right, now we'll go back and I'm going to fix my ramp because I kind of messed it up. And I'll put the crayon box back and the meter stick back. And now I'm going to give the marble a soft push. All right, so if we look at our meter stick, it didn't go much farther than just letting it roll. It went 6.5 centimeters. So how we'll write that, I'll show you. I'll write it and then I'll show you. All right, so under soft, what I've written is 6.5 centimeters. So go ahead and write that down in your journal. All right, and then the last test and the last roll for this is going to be giving it a hard push. So let me get it set up. Let me give my marble a hard push. And it went a lot farther that time, didn't it? All right, so if you can see it here, it went 18 centimeters. So under where it says hard, let's write 18 centimeters. All right, and that does it for trial 1. Okay, now we're on trial 2, and what I've done is I've made my ramp a little bit taller. So I've raised it up, and the ramp is now steeper. So I'm going to start out by letting it roll. All right, and if we look at the meter stick, it went 13 centimeters. So under trial 2, under roll, we'll write 13 centimeters. Okay, so it looks like this. All right, so we'll get it reset. Put the box back up here, and then we'll do it again, and I'll give the marble a soft push. Okay, soft push. All right, so looking at the meter stick, we've got 15 centimeters for the soft push. So under soft, I will write 15 centimeters. Okay, like that. You see it? All right, and now we need to give it our hard push. So let me get it set up again. Get the meter stick ready. And my goodness, it went off the screen. All right, so the hard push, I'm not sure if you can see it, but it went 37 centimeters. So I'll write that down under trial 2 in the column that says hard. Okay, now we're done with trial 2 and we just have one more to go. All right, for trial 3, I have raised my ramp up even higher, and so now it's even steeper. All right, so we've got everything set up, got the box and got the meter stick, and I'll let it roll. All right, it stops right there, which is 24 centimeters. So under trial 3, roll, we'll write 24 centimeters. Okay, and now I'm messing it up again. Now I'm going to fix my ramp again because I bumped it. Put the crayon box back and get the meter stick ready, and I will give the soft push. Let's make sure it's all even. Okay, soft push. All right. So for the soft push, I have to bring it back here because it went off the screen a little bit. It went 30 centimeters. So under soft, on trial 3, we'll write 30 centimeters. Okay. So it looks like that. All right. Now, I don't know about you, but I have a feeling that when I give it a hard push on this higher ramp, I have a feeling it's going to go pretty far. So I'm going to turn the camera like this so that we can watch the box go. All right, so I've got my marble up at the top of the ramp, and I'll give it a hard push. It just went all over the place. All right, so if I put it back here where it ended up, we are at 45 centimeters. So we'll write 45 centimeters on trial 3 and hard. So your journal should look pretty much like this at the moment. I know we've got a little bit of a glare from the light, but hopefully you can see. So we've got all our distances. If you didn't get all of these, then go ahead and pause the video until you have it, and then we'll move on. In all 3 trials, rolling the marble moved the box the shortest distance, and giving the marble a hard push moved the box the farthest distance, and giving it a soft push fell somewhere in the middle. Now, what about the slope of the ramp? What that means is how steep the ramp is. As the ramp got steeper, did the box move farther? Yes, it did. But still, even though the box moved farther, the steeper the ramp was, still rolling the marble had the box move the shortest distance, and pushing it hard moved it the farthest distance, and then again, the soft push was somewhere in the middle. All right, our third experiment is called Go, Go, Go. So I want you to write a number 3 and Go, Go, Go in your journal. And then I want you to write on the next 3 lines, 3 centimeter pull, 8 centimeter pull, and 14 centimeter pull. And I'll explain what that means in just a minute, but for now, go ahead and pause the video and then come back whenever you've gotten all those things written down. All right, for our Go, Go, Go experiment, we have a toy car, and it's the type that you pull back and then it will go. And we have a starting line and my meter stick. So what we're going to do is we're going to test different lengths of pulling the car back and seeing how far it goes. So that's what those numbers that I had you write were for. So for this first one, I've got the car and I've measured out 3 centimeters from the starting line. Okay, so I'm going to pull the car back until the front of it's at the starting line, and I'm going to let it go, and then we're going to measure how far it went. But we're going to have to do a little bit different angle on that, so let me switch the angle and then I will let it go. All right, so here we go. We have the car here. I'm going to pull back and let it go. And then we'll measure how far it went. So the car is exactly where it was when we did our 3 centimeter pull. And what I've done is I have taped some meter measuring tapes along the floor so that we can measure how many centimeters it went. So each one of these tapes is 100 centimeters. So there's 100 centimeters and there's 200 centimeters. It didn't quite go to 200. Let's see how far it went. All right, if I go here, it went to the 89. So 189 centimeters, and we'll go back and we're gonna write that in our journal under the 3 centimeter pull. So 189 centimeters is how far it went for the 3 centimeter pull. So we'll go back, we'll get the car, and the next one we're gonna do is an 8 centimeter pull. So we'll bring it over here. I'm gonna move this to 8. All right, and we're gonna do this one facing this way since it does travel pretty far. So I'm gonna put it here, pull it back to 8 centimeters and let it go. All right, so let's go see where it landed. All right, there's 100 centimeters, 200, and all right, let's see where we are. 253 centimeters. So for our 8 centimeter pull, we had 253 centimeters. So now let's go get ready for a 14 centimeter pull. All right, so I've got 14 centimeters from the starting line measured. So I'm going to pull back and let it go. 100, 200, 300, and it's not quite to the 400. I'm going to take it where it is and just scoot it directly over. All right, so if we go, we're at 87. So that was 387 centimeters. So let's go write that in our journal. All right, there you go, 387 centimeters. So your journal should look about like this. And if it doesn't yet, then go ahead and pause, and then you can come back whenever you're done. So what did you notice in this experiment? Did the length of the pull affect how far the car traveled? Yes, it did. Let's look. So the farther back I pulled the car before releasing, the farther it went. So you know that a longer pull, which is a stronger pull, makes it travel farther than the weaker pull or the shorter one. All right, our last experiment is called Direction Magic. So write in your journal number 4 and Direction Magic. And then come back, pause it, and then come back when you're done. In this experiment, we're going to learn how the push of an object can change its direction. So I have this ball here. It's kind of big, but it's really lightweight. If I drop it, you can see how easily it rolls. So it's very lightweight. And I'm going to roll it, and for each roll, I'm going to do 3 rolls, and for each roll, I'm going to try to change the direction it's traveling, but without using my hands. I'm going to use different objects. So for the first roll, I'm going to use a rubber band. So how do you think I can change the direction of a rolling ball with a rubber band? Well, what I'm going to do is I'm going to stretch it out as far as I can, and then I'm going to roll the ball toward it. And what happened? So the ball came toward it, and then it pushed against the rubber band, and then the rubber band then put its own force on it, making it roll away. All right, the second object I'm going to use is a plastic spoon. So how do you think I can change the direction with a plastic spoon? Well, does anybody play baseball? Maybe I can use this as a bat and use this as the ball. So as I roll it, I'll give it a push with the spoon to see what happens. Okay, so roll, and there it went, and it almost fell off the table. So I rolled the ball, and I gave it a good push with the spoon, and it stopped and changed the direction. All right, so my last object is a straw. So how do you think I can use the straw to change direction? Let's think of something I haven't done before. Well, what happens if you blow in a straw? I don't know if you heard that, but you can blow air out of a straw. So what I'm going to do, I'm going to have to move, and I'm going to roll the ball and see if I can move it with the straw. So roll. No, that's not a roll. Roll. All right. So the ball got close to me, and I blew the straw, and it kind of stopped it a little bit, and then I blew again, and it rolled the other way. So this time I was using air as a force to push the ball the other way. But at first, all it did was just stop it, because it didn't have enough force, like the rubber band and the spoon, to stop it and immediately move it away. So I had to give the air another push for it to roll away. So let's review what we've learned about force today. So we used the pendulum, and we were able to see that the strength of the force affected how far the pendulum swings. A soft push makes it swing a little bit, and a hard push makes it swing a lot more. We also learned that if you roll a marble down a ramp and into an object, then the strength of the push affects how far the object moves. So if you remember, just rolling the marble down pushed the crayon box just a little bit, and when we gave the marble a hard push, it pushed it a lot farther, and then the soft push was in the middle of those. And we also learned that the height of the ramp makes a difference as well. So for a ramp that is less steep, the marble won't roll as far in any of the scenarios, whether the roll, the soft, or the hard push. And if you go a little bit steeper, the marble rolls farther in all of those, or the box moves farther in all of those. And if you go even steeper, then the box moves farther again than in any of the other ones. But still, the rolling makes the box travel the shorter distance, and the hard push makes it travel the farther distance. And with our third experiment, go, 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 we learned that the strength of the pull, or the distance of the pull, as it was in our case, affects how far the object will go. So the stronger the pull I did on the car, which means the farther I pulled it back, the farther the car traveled. And we also learned that force can change the direction of an object that's moving. So you saw in the last experiment that a force can stop the movement of an object, and it can even push it back and change the direction a different way. I hope you've enjoyed this force lab, and I will see you next time. Bye.